All right. Today we are well into our chapter 9, and so the important parts of chapter 9 are knowing what the normal forms are, and how to make a database or a table that's not in BCNF into BCNF, and that's chapter 9. And you know, he likes to define these things in subkeys and superkeys, and I sort of went through it this weekend, and I remember now. I mean, all the innuendos and so on. But he has other in a textbook that's actually would be like the one that comes after this. He discusses these again, and you know, in other terms, and so I'm going to try to discuss them more or less in the terms that I learned them. But here at the end, he discusses this. Let's see, what was this? This is not in BCNF. Okay, let's say you have a table just like this. It's not in BCNF. Okay, this one and this one are the key, right? I mean, this is just your regular old SP table, but it's got the S name in there along with it. So this and this can be a key, and this and this can be a key. And so the problem is you have a relationship between two attributes that could be the key, that could participate equally in the key. It's either the whole key or the same component of a composite key, or you know, they could exchange each other. So that's not so bad, but what is bad then is you have this other field in here that if it is this field is this field depends on the key, right? And the key is this plus this. Well, the trouble is when this plus this is the key, then this thing still depends on this, which is not the key. Okay, so what we need to do is break this down one more time into where we get something like this and this, or we get this and this. Okay, but the point is that these two things, which depend on each other, are in its own table, where anything that depends on anything else has to be able to be a key. If it's in BCNF, anything that depends on anything else has to be able to be a key, basically. So this depends on this, but this cannot be a key. Here, when we just have this table, and then we just have, let's say, this table, or this, let's say, this, and this, then we have this depends on the whole key, so it's in second normal, it's in third normal, and it's in fourth normal because we don't have anything that depends on anything that cannot be, let's see, this, yeah, they cannot be, we don't have anything that depends on anything else that, where the thing that depends on cannot be a key. Is that right? I'm trying to explain this in the terms that he's presented here, but can't. This depends on this, and this. Okay, this depends on the whole key and nothing but the key. So it's in third normal. It's in fourth normal because you have nothing that depends. You have no non-key attributes that could be dependent on. You have non-key attributes that are dependent on another non-key attribute. That means it's not third normal form. All right. I tell you what. I'm going to go, and I wish I brought that other textbook. I don't have. I was looking for an online copy of that other textbook. There can be a functional. BCNF says, in essence, the only functional dependencies are functional dependencies of keys. How can this requirement be violated? Simplifying somewhat, there are two basic ways. A functional dependency, there can be a functional dependency out of a proper subkey. Okay, in which case the rel var is not in 2NF. That makes sense, because the functional dependencies have to be out of the whole keys. Or there can be a functional dependency out of a non-key, which in case it's not in 3NF. Okay. Anyway, let's. I'm going to go to the quizzes, the two quizzes that I've set up for this week, and they should be. I'm presenting them both to you at the same time because if you look at them. Because if you look at one without the other, you're going to make some assumptions that only should be made in one or the other. Okay, so and it kind of goes to how we end up having to define these higher normal forms that are higher than BCNF, and that's fourth normal and fifth normal. And fifth normal, for example, you cannot or you want to break it down into fifth normal form, but to determine if a particular tuple is valid or not, you have to join the tables together, and it's only if they join properly and they join into a relation. In other words, there's no rule violations in the joined table, then it's a valid tuple that belongs in the database. So I think you can go to resources quizzes and see 15 and 14. So let's look at 14 and 15. So this is 14. So this is a quiz that has evolved over the semesters, And I think this is a sort of a refined version of it. So imagine we have, so imagine you're here at UH, and you decide that you want to keep keep your own transcript, keep your own record of all the classes that you've taken here until you graduate, and it'll be good because, you know, when you're writing your resume, you want to go back and make sure that when you talk about your skills, you cover all the skills that you actually have or have learned, but perhaps have forgotten about because it's a class that you took 2 years ago, for example. So, so you can imagine having a table that looks like this, and we'll call it My Classes. And you know, you may have a table like this semester that looks like this. I don't know. So we're going to keep track of the term, and there might be like 8 terms or 8 or 10 terms or so that you are at UH, and there are these courses, and these courses have titles, and these courses have a number of credits, and each course that you took had an instructor, and it was on particular days and times. You know, you might want to somehow remember that, or it's good when you're starting a new semester and you've got your schedule there in your room. And then, you know, after the course is done, you would want to put your grade there. Okay, so the task here is to break this down, is to normalize this, because right away we can see some things like, no, I don't want you to make any assumptions about sections of course, because you would never take the same. You would never take 2 sections of the same course in the same semester, right? Right? You can't, right? You know, you can't sign up for Moore's section of 314 and someone else's section of 314. Okay, so we don't really need to think about sections. Now, this doesn't preclude your taking a course twice. There could be a number of reasons why you want to do that, and I, in fact, did a little bit of that when I was in undergraduate school, and went back and retook some courses that I did poorly in because I was trying to get my GPA up to graduate school. But anyway, but that would be in a different semester, so we could take that into account when we take the take the term into account, and that takes care of a course being taking a course more than once. The title would depend on the course, but it turns out I happen to be on the curriculum committee at right now, and course titles change. Throughout 5 years, course titles changed. In fact, this course title changed. When I started teaching this course like 4 years ago, 3 years ago, the title was Data Storage and Retrieval, because that was the name of the course back when it started. Back, it was like the first course, the first computer science course. The computer science department was started by 2 fellows, Wes Peterson and Norm Abramson. They came from the electrical engineering department, and Wes Peterson's claim to fame is he wrote the math. He came up with all the theorems for the math for error-correct codes in disk drives. So he didn't make any money like patenting it or anything, but he got a lot of awards. You know, $1 million awards because he's such a smart guy and they fly him all over. So anyway, there's him, and so we had a class called Data Storage and Retrieval, which is storing data onto disk drives. And you know, the course originally, it was very important to learn about disks and cylinders and sectors and densities and so on. Anyway, that was and the credits can change. It doesn't happen very often. Credits can certainly be different, though. Like ICS 101, Manoa is 4 credits. ICS 101 on any of the other campuses, it's the same course, but it's only 3 credits. Of course, you know, the instructor is not necessarily connected to the course. Like this, I have more than one instructor for the same course in the same semester. Days, well, Okay, all of these fields, the way we've set this up is this can be the key, the primary key. This would uniquely identify any single row in the key for the time that you're here. Also, this plus this could serve as a primary key because you're never going to schedule it in a term. You're never going to have two classes scheduled at the same time. Yeah, I know it happens, but let's exclude that case. Okay, so at Tuesday, Thursday, 12 to 1:15, you can only be taking one class in your schedule, and so that can uniquely identify a record. Okay, but really you can't draw any other conclusions about any of the other about any relationships between these courses, between these attributes and the primary key. So really all we can say is that this is the primary key, or this plus this is the primary key, and all these other fields are functionally dependent on the primary key. And there's not really any other functional dependencies in between these fields. And that's because we don't know anything more about these fields. We're not smart enough to know that, well, in a particular term, a particular course is going to have the same number of credits, so there's actually kind of a relationship there and all that. So assume that course determines title and number of credits. So course determines the title and the number of credits. Okay, wait a minute. So there are some dependencies here. But two different courses could have the same title, even in the same semester. Okay, so course determines title and the number of credits in the semester, and but two different courses can have the same title. So all I'm saying is that this determines this. This is not consistent with what I said earlier, is it? Okay. Wait. The course can be repeated and titles. Assume a course can be repeated and that course titles and credits can change over time. Okay. It would be. Oh. Okay. So term plus course determines title and credit. Okay. This here is kind of not. The only conclusion that you can draw from this is that title cannot be replaced with course, because you can have two courses that have the same title. You could have, Psychology 590 titled Research, and then you have, Anthropology 660 entitled Research, or something, just something like that. I'm just making those up. So I'm explaining to you that it's this plus this, or this plus this can be the keys. So it's possible to have an instructor for two classes in the same semester, so you can't use instructor as a key, and assume your class times do not overlap. So the fact that two different, this should say course, assuming course plus term determines title and the number of credits, because that's got to be consistent with course titles and credits can change over time. Okay. In any one semester, ICS, in any one semester, all the ICS 314s are going to have the same title and the same number of credits. But fall 2018, ICS 314 might only have 3 credits, whereas fall 2008 314 may have been 4 credits or something. I don't know. I don't think computer science never had a history of that, but I know electrical engineering has had a history like that. The engineering programs back in the 60s and before were all 5-year programs, and then there's this big emphasis, this big drive to make all of them 4-year programs, and so they just ended up, just reducing the number of credits for a lot of courses. Anyway, so I want to identify all the candidate keys and the sets of all the sets of attributes that could be a key, the primary key, and then I want to identify all the functional dependencies and what normal form it's in, and then reduce them down to tables in BCNF. I can't remember how many there are. There are like 4 of them or something. Okay, so the next quiz, though, it's the same set of data, but we learn a lot more about it because we're looking at the class, at the the actual scheduled classes. So if we actually look at the scheduled classes, this is the one for the ICS department this semester. And if you look at this one, this is like where it starts. And you start by selecting the institution, or you start by selecting the campus, and then you drill down, and you get to the courses here, like fall 2008 Honolulu Community College, Honolulu Community College, Information Computer Science, ICS 101. Okay, same course, ICS 101, but it's only 3 credits. And when I'm on the curriculum committee, and when we're approving new courses, we have to go and look at all the courses, the same course numbers, and for all the other campuses, and we got to make sure that they all kind of match up. But so sometimes they don't. All right, so for this problem, I'd like you to so we have on that page something that looks more like this, where we have let me come over this tab, where we have the institution. No, we don't. If you click on the CRN here, you see, and in fact, if you roll your mouse over, you look down at the bottom down here, you see that it says, it talks about down here it says, Manoa, the term, this is 2019-1, which is fall 20. This term is in the database is the first term in 2019 of the 2019 school year. Got it. And then the C is the CRN. So we can conclude that the institution plus the term plus the CRM is the unique identifier for the section of the course. Okay, I don't know if CRNs are unique to this term. I know they're not unique to the cross terms, but they might be unique to the terms. But I don't think they are. I mean, I don't think for sure you have Manoa, the term, and then the CRN, and that uniquely identifies a course for that semester. And so you would look at we have institution, term, CRN, and then we have the course, which is ICS 321. Section 1, it's 314 has like 3 sections. The title of the course, the number of credits, the instructor, the days, the time, and the room. And so here, it's like we're learning more about the database. Okay, and that is exactly how databases start out and are designed. And at the time of their design, there. Everything's in BCNF, real nice in BCNF. And then the database, the scope or the domain or whatever expands a little bit, or they learn more about it, or they add some tables because it starts to absorb more data, and then you end up finding out these other relationships, and all of a sudden you have the same database, and it was in BCNF, but then when this new information comes along, they're not in BCNF anymore. They're in something else, and so and that's where we need to learn about these things called multi-value dependencies and join dependencies, because that's how we keep the data, keep the integrity of the database sound when we're only dealing with a subset of these attributes. So here we assume the course titles and credits can be different. The course titles and number of credits can be different on different campuses for a course, and can change over time. So we have ICS121, Manoa, fall 2018, Manoa, and it's 4 credits. It's the same name, course name, and we have and on the other campuses it's 3. So that's an example of the difference. There's other courses like Anthropology 151 can have different names, like the Big I of the University of Hawaii, Hilo, has a different title, and that's just legacy. That doesn't happen anymore. But anyway, and also courses can be cross-listed, so it's possible 2 courses can have the same room at the same time. They used to cross-list in math, in computer science and electrical engineering campuses that had both. They would cross-list like the logic design course, because both have to learn gates and flip-flops, or presumably, and so it would have an EE course number, and it would have an ICS course number, and it'd meet in the same room, same time, the same instructor. So that's possible. Now, when we go back to the earlier quiz, that would never be possible. I mean, you would not be allowed to sign up for 2 courses that are the same course, but they're cross-listed. So we don't have to. So there's cases that we didn't have to consider, so we could just rule them out in the previous example. But now we're doing a larger view of the database. Okay, so I'd like you to identify all the significant functional dependencies, and if you look at the questions in the back of this chapter, where they ask you to list all the functional dependencies of, for example, the supplier's parts database, and there's a whole bunch of them, and that's because he's kind of lists all possibilities. He lists a bunch of ones that are really kind of redundant, like the SNO determines SName, status, and city. And then the next line is SNO determines SName and status. And then the next one is SNO determines SName. See, so it's like all the possibilities. You, of course, don't have to do that. Just the main ones. Just the main ones, which lead you to what the BCNF form is. And so, like, for example, for this quiz, you would list that, this depends on these 2 things. This depends on these 2 things. This depends on these 2 things, and so does this, and so does this. But then you'd also have that this would depend on this, or this plus this as a key, so those are, they're different. There's significance, and then one's just not a subset of the other. It's not just a bunch that are subsets of a larger one. But you're going to have one where this is where you have this is dependent on this plus this is dependent on this plus this, right? Because the course in a particular term for an individual in a particular term, since there's no course overlapping, you can't take more than one course, or the same course. You can't take two sections of the same course and all that. In fall 2018, ICS321 is exactly the same as Monday, Wednesday, 1:30 to 2:45. They're interchangeable. One determines the other. So 321 determines this, and you can say this determines 321. So both of those functional dependency relationships will be in your list, but you're only going to have one relation. You're only going to have one table. You're going to have two of the same tables, one where the primary keys are defined differently. So and that's because you generally choose a convention. You choose, well, this is going to be my primary key, and I'm going to make anything else that's identical, that's equivalent, that could be used as a key. I'm just going to say that's dependent on my primary key. But they have to be in separate relations, because otherwise it wouldn't be in BCNF. Okay. So you have in BCNF, you cannot have a you cannot have a candidate key attribute dependent on only. It's not that you don't. When you're trying to determine between BCNF and 3NF, you're looking at just keys and candidate keys, and all of the functional dependencies have to be between keys or candidate keys. You cannot have any functional dependencies. If you have functional dependencies between partial keys or partial candidate keys, then you cannot have any other functional dependencies that do not involve keys or candidate keys. So that's where you'd have to split. And so that's why when you have a table where you have this, where you have these two things in there, if you have anything else in there, like this and this and this and this and this and even this, that's reasonable, because everything is determined by term and course completely, both those two. But if you have this and this in there, then you have the additional relationship where you have this, or where you have this determines this. So we have a functional dependency relationship between part of the primary key, and it's not non-key attributes dependent on the primary key, part of the primary key. These are candidate keys. These two fields make up a partial candidate key, which when paired with the other thing that this is paired with, can be a replacement for the key. So so let's go back to this other one. Okay, so first of all, you identify the functional dependencies, and I told you. Then you normalize the table. You don't have to. These questions are slightly different. So first you identify the functional dependencies, and then you normalize it, and then what I want you to do is imagine that you have this other table here, which is probably in there. It's for each person. it's for all your grades. All your grades, I'm sure, are in a table that looks something like this, where you have your UHID, you have the institution, Manoa, you have the term, fall 2008, you have the CRN, which is the CRN of the course, and then you have the grade. Okay, so these three things uniquely identify the course, that you took, and then this means not everybody that took that course, just you, and then your grade. Okay, so let's say you have this table and you have this table. Okay, so you have this table for all the courses in the world since you've been here, and then you have this table for all the courses that you ever took for you. And what I want you to do is give me the SQL statement to produce this table, which is this table. It's not that hard, but it's sort of you got to get your mind around it a little bit. Actually, not really. It's this join with this. Natural join. You can do natural join, I think you can. And for you, you have to just put, the where clause is for you. And it's got to be yourself, so you got to do it for you. The grader on the key to this. There's a table there with your names, your IDs. So he's nobody's going to cheat and take somebody else's and put it in there and go, oh, and not forget to change your ID. But just in case, I teach this I'm teaching this programming class, and so I have them. I'm not having them hand in their actual program that it runs, but I'm having them hand in listings and screenshots and all this other stuff. And I can see students, they have the screenshots and they hand in the code, and it doesn't match up. I mean, it's just little stuff like, oh, there's a space here and there's not a space there, and just that kind of stuff. That's just how you. That's just anybody can do it. I mean, anybody can grade and find little discrepancies once you know the language. And so I try to make it obvious, and I tell them about it, so no one gets caught, so no one is just gets caught, just trying. I mean, it's like so obvious, and it's because they're not, because they know so little about it. I mean, that it makes it easy to catch them. So anyway. So this way, if you end up with somebody else's code, you're going to have to understand it well enough to know that your UHID goes in there instead of his or hers. So if you think about this, and I was going to have you answer this instead, where you have a table of students, or let's say you start with a table of of all the students. Okay, so it's one record per student. So you're in there as one record. Okay, now what would and then you take this and you natural join it with this. Okay, you take this natural join with this, and you end up with this table. But it's got everybody's UHID in there and every course they ever took. Okay, so it's going to be this big, huge table. And then you take the image relation from your record, that's just you looking into that joined set of tables. And that would give you this. But you know, I want the. I mean, I know that's a way that I sort of structured the problem in my head, and it kind of goes to it kind of proves to me that once you learn these terms or these concepts like an image relation. Okay, so I've seen it for about 4 or 5 semesters now. So now I'm starting to think that way, but it's kind of worthwhile, and it's the kind of thing where if you go out and your job involves databases and you're doing a lot of database stuff, you know, a lot of this stuff is going to become second nature, and when it becomes second nature, you're going to probably start thinking about some of the problems that you're working on in some of these terms that in some of these you know, incorporating some of these concepts that we're learning in this class, and that's kind of the point of it. All right, so next time I don't think I'll go any further. I've explained these 2 quizzes, and next time I'm just going to go over examples of giving you a table and breaking it down, and breaking them down, and that way explaining one more time in my terms what the normal forms are, and how to go from one normal form to another normal form. Finding a table that's in 3NF, but not in BCNF, taking that table and converting it into BCNF tables, that can be tricky. And sometimes you don't want to do it, okay, it turns out. You end up trading off losing something, and you choose, you're going to lose the protection of keeping redundancy out of your database by going to BCNF. You're going to forgo that because there's something else you want, like you know, like you want to make sure that mozzarella as a topping is always considered a cheese and not mistakenly being considered a meat. You know, you'd rather, let's say, have your database enforce that rule as opposed to a rule where no. Let's say you want to enforce the rule of 3 toppings on your pizza, like one kind of cheese, 1 kind of meat, and 1 kind of vegetable. Let's say you sell pizzas like that, 1 of each, and so these orders come in, and you can structure your database where you're making sure that each one has 3 items, but you might accidentally say that a meat is a cheese or a cheese is a meat. Maybe you want to be able to do that because you want to give your friends some you know, more meat or something. I'm just saying, but or so you can enforce that, or you can enforce that you know, mozzarella is always a cheese and so on. And if you want to enforce both, then you have to add another table, and you have to join. It has to match. It has to be consistent with the joined version of the tables with, you know, relevant keys defined, and then that can enforce all of the things that you want, and that's where you end up distinguishing between 4th and 5th normal forms too. So anyway, so I'll continue. We'll continue this next Wednesday, and then we're going to have one more class on next Monday on this, and I think in that one I'll talk about some of the higher normal forms. But the important ones are 3NF and BCNF. Those 2 are just very important for you to know, and those will carry you through, you know, the rest of your programming life, pretty much. All right. Are there any questions? All right? So I'll see you next time. Thanks for watching.